Great. It was story about the how to mount the jig itself. But question still is, why we need all these yellow stuffs, another blue stuff, and so on? Why we need it for? Once again, remind you that it does not come about one assembly jig. It's a family of assembly jigs, and this family of assembly jig has so-called merit places, coordinated places. Now, for instance, like the jig for center wing. Center wing will contact to the wing at this place. The jig for aileron, and maybe it's flap, maybe it's aileron, maybe it's flaperon, whatsoever. The family of jigs for the same airplane, and they all have places which coincide to each other. First, and secondly, all these jigs should give results which are coordinated by theoretical outlines also. Plus to this, if it comes only about assembling, it's enough to have family of mounting standards in this case. Plus to this, we have a need to produce all the tooling for parts manufacturing, and these parts, they have also complex outlines, and it's inconvenient, it's extremely inconvenient, at least before appearing of numerical control machining. It was available only by hands to do these contours, yes? Inconvenient to measure such contours. That is why better to produce such contours by molding, by copying principle, not by measuring principle. This approach was realized in this idea that first we do a full-scale model of airplane. However, while it's sound now, yes, they did. And even in a movie about Boeing 747, you might see, I hope you have seen already, full-scaled wooden mock-ups. Full-scaled wooden mock-ups of Boeing 747 and full-scaled wooden mock-up of passenger supersonic aircraft, which never was produced after in America, but it was designed and it was technologically prepared already, potentially, as they handed that mock-up. It means that they have already started manufacturing preparation, lead time. But they stopped because they understood they be in competition with Europe and Soviet Union, and Soviet Union has produced its Tupolev 144. Europe has produced Concorde by that moment, and Americans already understood that these supersonic passenger aircraft, they are not economically rational. They are ecologically harmful, they are too expensive, so on and so forth. They decided to stop this program, passenger supersonic aircraft. But they had wooden mock-up, and you might see it in a movie, as I said. So we do mock-up, either wooden or made of plastics, and this mock-up will be copied in two different ways. This surface may be copied, the whole surface, to repeat it in the tooling for manufacturing the punch, for instance, bending punches for skin, tooling for parts manufacturing. And on other hand, it may be copied, but not the surface as a whole. We don't need the whole surface, as we need only some locators. It will be copied to these contours of jig and to junctions of jig might be copied. But there is no junctions. Do pay attention. It's a problem. So what they do? Very similar to what we did in the jig. After surface standard system, family of surface standard, for wing, for center wing, for fuselage, for everything, they made. Next, they are placed together, like assembled together as mock-up of the whole aircraft, wooden mock-up. Check it, inspect it. If everything is perfect, then they are dismantled, disattached to the separate aggregate surface standards, and we continue work with them. When it comes, each time we use molding principle, attaching something and copying by molding principle, by casting practically. Whether it comes about casting with sand glue mess, for instance, or it comes about epoxy resin or some another kind of cement, doesn't matter. It's just molding. You have something what is liquid, and makes this liquid became either polymerizing or it became hard. like sun gloomes, for instance, да? Так, what is next? Surface standard, place it in frame of counter standard. This time it's called counter standard, not a jig. Contours of surface standards, they are copied to non-finished locators of counter standard. You see the same story, yes? The same story. It means that surface standard should be greased somehow or protected with the film. These locators, they are placed first to the surface standard and clamped temporarily. Next, we clamp them with permanent joint to the frame of jig through these fork type connectors. What is next? Why fork type connectors? Because they should be removable. We'd like to, time to time, we'd like to, which one is openable better? We'd like to open and close them time to time, yes? That is why we use these connectors, not permanent joints. Why we need to open them time to time? Remind you, we need to locate something inside and to remove something. If they are not movable, it's not possible to remove the whole item. Separate elements you may insert inside, but as a whole, you are not able to remove it next. Так, what is next? After we did this counter standard, this thing, but it still has no these junctions, remind you. Remove surface standard from counter standard. What for? Because we are going to place here this red frame with non-finished locators, templates of mounting standard, as you might see. And these things, these gauges, they are also yet either not joined at all or they are not finished. We have no place to copy it from, yes? Next, to the gauge. To the gauge, do forgive me. To the counter standard, to this one frame, we are placing the frame of mounting standard, which is not finished once again. What for? Now, in contrary, we are going to copy from locators of counter standard, which are finally manufactured now, contours to templates of mounting standard, which are not finally manufactured by this moment. So we finalize, we are finishing everything in mounting standard when it comes about contour, but we are not able to make gauges here, no? Because, remind you, there are no gauges in counter standard yet. What we do next? After we finish all the contours of mounting standard in the counter standard, we remove mounting standard, and once again, you have the whole family of these mounting standards. And like it was with these yellow things, with surface standards, you do the same to the mounting standard. You bringing them all together in one place, assembling them together, aligning them, checking their outer contours, technical inspection, and not in terms coincide, not coincide. It's something like procedure of leveling, where you align them in proper position, locate them with respect to each other. And now you are finishing all the gauges, even in assembly with another mounting standard. No, preliminary, of course, you did something by using measuring this time, not copying, no place to copy from. And after you preliminary did something like rough gauge, you finalize them in assembly with another mounting standards. In case of our wing, remind you, we need to join mounting standard of wing to the center wing mounting standard. It will be some another mock-up. And to the flap or aileron mounting standard, it's already third mock-up. So altogether, this system of mounting standards, it's checked. It's assembled together, checked. If necessary, it's a bit changed in order to provide accuracy and functionality of all the elements. And next is dismantled, deattached again. All these procedures is extremely important and it's necessary. What it's for? It's necessary to make coordinated gauges at the mounting standard in each particular mounting standard. After this, mountain standard comes back to its father, to the counter standard. And what for? No, question is why. In order, next time, when you'd like to check mountain standard in turn, you may check by this counter standard, you may check only outer contours if you have no these locators, yes? And in order second time, third time, and so on, you able to check mountain standard gauges after you place it mountain standard, finish it in counter standard, remove it, familiarize, let's say, them with another mountain standard. Did everything already, it's finally mountain standard. You bring in this final mountain standard to finish this counter standard. And in counter standard will appear locators of gauges very similar to what we have in a jig, but they will have another accuracy, higher accuracy. No, and that's it. The family of tooling is ready. Surface standard, counter standard, and mounting standard. And after this, we may start manufacturing of jig. And once again, mounting standard, the same, may be used for producing of some identical jigs. No, for instance, you need to cover a great program of manufacturing, and it's not enough for you, the only jig for wing assembling. You need 5 in order to be on time with all your program. These 5 jigs, they may be assembled, mounted by the same mounting standard. In this case, they give extremely close results. Interchangeability of wings that produce it in such wings, in such jigs is extremely high. Next, mounting standard will be used for checking the jig contours, both and gauges of the jig, or forgive me, locators of contours of the jig, periodically in some period of time. And in order time to time to check mounting standard itself, whether it's yet correct or not, you are bringing mounting standard into counter standard. And in counter standard, you may check mounting standard. And in turn, once again, if you'd like to check mounting standard, you are referring to the surface standard. No, of course, only by surfaces. Extremely complicated procedure, extremely long in pre-production, in lead time, and extremely expensive, especially when it comes about big airplanes. And as I said you, before appearing of numerical control machining, we had no another choice practically when it comes about high speeds, when it comes about the high accuracy demands, only mounting standards. But with appearing of CNC machining, it became a little bit easier to prepare manufacturing. And not in all cases we even have high demands to accuracy, because demands to accuracy depends on the speed airplane flies. And when it comes about fighters, or when it comes about the places like cockpits or places with control surfaces at the rear contour of the wing, even by now, we still use this mounting standard method. Another story is that mounting standard, surface standard, or even mounting standard itself, it's maybe not produced by so long procedure. It's maybe produced certainly not from lofts and templates. It's produced already by CNC machining, because such surface standard manufacturing, this yellow zinc manufacturing out of wood, it's also extremely complicated procedure. Like we have lofts, next we have rough frame and very exact, very accurate templates, assemble everything together, fill it with special compound, or stuff it with wood, next we polish it. It's literally some weeks for each of them. And it's maybe done only with very high qualified employees. So in this case, decision like to use CNC machine, of course, it's some solution for this problem, at least to produce the surface standard. But anyway, if you'd like to do assembly jig, you can't produce immediately by CNC machine because of design of assembly jig, because of sizes of assembly jig. It's not no, it's not possible. It's possible, yes, but it would be extremely inconvenient and it would be too much expensive. Once again, about advantages of this method of jig mounting. Very high accuracy of results and very high interchangeability of results. Reliability of this technique is extreme. Accuracy of mounting the jig in this case that you are going to calculate by the word in one of task of your laboratory work is up to plus minus 0.3 millimeters. It's great thing. On the other hand, it's long and extremely expensive technique of manufacturing the jig. And expensity, in this case, it's like rewarding, let's say, if you need to meet high accuracy demands, like fighters, for instance, especially supersonic fighters. If it comes about the places with specific demands to accuracy, like cockpit or some in other places in the aircraft, even in passenger aircraft, it may be, especially if it's supersonic or high-speed passenger aircraft. No, actually, I said everything, I hope.